we're live. Excellent. Oh my goodness, what a day. Um, Good morning to one and all who are actually joining us this morning. Um, it looks like I have three current viewers in the stream. Let me double check something real quick. Yeah. Oh, looks like I have four watching now. Regardless. Um, yeah. I'm going to start the lesson that I would have done in class in a few minutes. Um, you guys just give me like a thumbs up or a hello. There he is in the chat. Give me a thumbs up or a hello in the chat so I know that you can hear me. Number one, and that the settings are all set up and good. I know, Aiden. What a day! What a day indeed! What a week! What a year! What an everything! I don't know. I don't get it, but that's where we're at. Um, yeah, these are interesting times. I was not anticipating that they would shut. I was anticipating they would shut things down after Thanksgiving. Like that's what I was thinking about. And then everyone's telling me, no, the governor's, the governor's not gonna do that. Schools are actually where it's, things are working well in the school. Yeah, things are working well. Blah 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 blah. And I'm like, okay, all right, it's a good possibility. It's just, but that's where we're at. That is where we're at right now. So, yeah, I don't know. Who else is here? Who else is in this live chat right now that I can call out by name and yell at or something along those lines? Aiden, why don't you set your team's lineup? You should have set your lineup. Hold on, I can do something here. I just gotta make sure I get it set correctly. There we go. Get into that one. You gotta see what I can do here, because I love streaming on OBS Studio a lot more than I do anything else. So check this out. Japoom. Was that the one I wanted? So then I can do that, and then Japoom. There we go. Look at that. I can show you, and look, you can see my little face right there too. I can show you where things are in real time. I can go to the scoreboard right here, and I can show you that my team is definitely going to win this game. You know, I'm just looking at my. Let me look at my team. Look at my team schedule real quick. If I'm looking at my team schedule, I got two more games, one against Team Quinn and one against Team Hair DeSanto, which I lost to Hair DeSanto here, and I beat Team Quinn over here. So we'll see how that ends up being. And then if I win those two, I'm in a pretty good shot. If I lose both of them, okay, I think I'm good now. Yeah, I think if I lose both of them, I'll still be in the playoffs. We'll see. You traded your good players. Why would you trade your good players? Where are you trading good players? Hold on. Let me go to transactions. Transactions? No, 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 no. Recent activity and just transactions. Who'd you trade? Well, AJ Green, I think. Oh man, what are you trade? What are you doing? I don't know. Whatever. Anywho, so we're gonna get started. Let me change the window out of here and go back to top down. There we go. Yes. I have my own little top-down setting. So again, it looks like I got 10 people here. Give me a thumbs up in the chat. Let me see who you are. Let me see who's here. Let me connect some names and faces. I don't know, whatever. Again, I'm just confirming that everything works properly. Obviously, Aiden can hear me. I want to know that the rest of you can hear me before I start my lesson for the day. So, while you guys are doing that, ooh, there's a private comment. Nice. Okay, sorry. I'm just losing my mind. Anyway, but yeah, people don't want to say anything in the chat. People don't want to post anything. Whatever. You make me sad. I know you're here, Aiden. You're the only one that's here. You're the only one that actually uh, thinks, man, Mr. Markey, I'm gonna respond to your comments because I respect you. And then see Ryan, he just responded because I guilted him into it. You know. So there they all are. Anyway, fun fact: before I actually, what's up, guys? Before I actually begin the lesson that I would have done in class, um, I don't know who was in the live stream when it happened, but I think it was like 2 or 3 weeks into quarantine. I was doing a live stream for Algebra 2, and doing that live stream for Algebra 2, I paused for a moment. I'm like, that sounded like my daughter. It sounds like she's crying. Okay. And then it turns out that she had broken her arm. She'd fallen off my son's bunk bed and broke her arm. Oh, poor thing. Poor, poor thing. But yeah, that's what we got. Anyway, so for you guys that are here, thank you. Number one. Number two, in Google Classroom, there is an assignment that I just posted. That assignment is not going to be due until Wednesday. During this live stream, I am going to help you at one point set up the problems on that worksheet. So by actually being here, by watching this perhaps later today or tomorrow, for those of you who are not here, um, this will be very helpful. I don't know what she's saying no to. What are you saying no to? What is that? I don't know what you're saying no to. I don't know if you're saying no to my daughter breaking her arm or no to me assigning you guys work. I'm going to assume it's the work part. I don't know. I have no idea. But check me out. I'm back. I'm back with my little setup back home. And it looks phenomenal. And I got multi-cameras going on at once. I got my camera here, and I got my camera here. It's so good. It's so good. Anyway, see if I can lower this just a tad. Yeah, that might be a little... No, I don't like that. I don't like that at all. Yeah, I don't like that at all. I like it when it's bright. There we go. I like it a lot better when it's bright. So we'll go to that. Anyway. Oh yeah, I know. Her breaking her arm, that was so sad. She was on a soft cast for like a month. Yeah. Anyway, she's never stopped. Okay. So today, I'll have to do it, but ladies and gentlemen, if you do not already have them out, I'm going to need those notebooks out and open. Love it. Today is the 23rd. This is going to be called Angles Continued. There's a lot of various things that I want to do with you guys in terms of angles. And we'll get into that. So first, let me give you a little bit of a reminder in terms of how to deal with these angles. Let me change my screen over just a tad. There we go. That makes me feel better. There we go. Okay. So let me give you a little reminder in terms of angles. Can you see that? I don't know if you can see that. What's going on there? Why is that so bright? Hold on. I gotta change a setting real quick. Why is this not working? I can't read what I'm writing here. What is going on here? Oh, there we go. I clearly wrote on the page, but you can't see what I'm writing here. Why is it so bright? Exposure, blah, blah, blah. That's so weird. People... Alright, I'm gonna have to do it that way then. Alright, we'll do it this way for now. I'll have to figure out my settings later. But regardless, I noticed that you couldn't see what I was writing, so I do apologize for that. Let me give you a reminder as to how to deal with this kind of stuff. So first, so ka toa. SOHCAHTOA, as I reintroduced, I should say, last week, is the way in which triangle angles relate to each other in regards to the adjacent, the opposite, and the hypotenuse. So, just as a very basic kind of example right here, of course you're writing this down, I'm just creating a very basic 3, 4, 5 triangle. Now with this 3, 4, 5 triangle, obviously this is a Pythagorean relationship, but that's besides the point. That's besides the point. If I label each of these angles, let's say I label this angle, let's say I call this angle B, and I call this angle A, and I call this angle C, just for the sake of argument. Let's say I just label those angles. And let's talk about angle C, just as a starter. If I'm talking about angle C, actually, you know what? No, I don't want to talk about angle C. We're going to talk about angle. I want to do something that's not going to be. Yeah. Let's talk about angle A. We'll talk about angle A. I'm debating and I just changed my mind. We'll talk about angle A. So if I'm talking about angle A, I'm talking about this angle right here. The opposite angle to angle A is 3. The hypotenuse is obviously remaining 5. And the adjacent angle to angle A is 4. Just for again, the sake of argument. If I were going to say, let me do it with the opposite and with the hypotenuse. The opposite and the hypotenuse. Then I would say something along the lines of, well, sine of that angle is equal to the opposite over the hypotenuse. And if I were to solve that, I would need to break out my calculator. You guys can see that pretty well. Yes, you can. Yes, you can. Again, for some reason, I don't know why my light is not working the way that I want it to. It's like way too bright when I turn it on. So I'm going to turn that off for now and fix that later. If I was going to be using the graphing calculator in order to solve what that angle actually was, first and foremost, I would need to make sure I go to mode. You can see that right there. See it a little bit better. There we go. You would have to go to mode. My writing's a little weird. You would have to change radians over to degrees. I wish I had a better way of showing this. I don't have a graphing calculator to pop up on my screen right here. But you need to make sure that you change radians to degrees. Make sure that you do that. If you do not change radians to degrees in your mode, then everything is going to fall apart. You need to make sure you set it to degrees. From there, if I were to solve such a problem as this, angle A would be equal to the inverse of sine over 3/5. This is what we did last class. I'm just reminding you as to how to do these things before we jump into some more problems. If I did the arc sine of 3/5, that would give me approximately 36.87 degrees. That would be angle A. Now, I'm going to stick with angle A for a moment because I just did angle A with the opposite and the hypotenuse. I could also say, if I were going to use, I don't know, the adjacent and the hypotenuse. If I was going to use the adjacent and the hypotenuse for angle A, I would say that, not sine now, cosine of A, because if I'm going to be using the adjacent and the hypotenuse, the adjacent to angle A would be 4, and the hypotenuse would be 5. If I were going to do that problem, I would have to do the arc cosine of that fraction. And again, I do apologize for the quality of my calculator right now. My lights are not working the way that I would have hoped they would. But if I were going to do arc cosine, 4 divided by 5, you can see it gives me the exact same numerical value, 36.87 degrees. That is what SOHCAHTOA allows you to do. If you have two lengths of the triangle, you can figure out what the angle is. There he is. If you have two lengths of that triangle, you can figure out what the angle is. Again, with TOA, I'm just going to do this one in the calculator. If I was going to do angle A again with opposite and adjacent, I would do arctangent opposite over adjacent. And you can see, again, it gives you the exact same numerical value. That's what's really nice about SOHCAHTOA. It doesn't matter which one you end up doing, but depending on what they give you, you may be forced to use one over the other. This is just, again, a reminder as to what you did in geometry. Again, I apologize for the PTSD of it all. So, if we're going to wrap up our game from the other day. And again, all of the stuff that we did and the cards that I collected, the choices that you guys had, I know that most of you picked soccer. It's all in my classroom, and I haven't been back to my classroom, obviously, since. So there's nothing really I can do about that. But we did the golf shot, and we did the soccer kick. The last one that we didn't do was the hockey goal. So I wanted to finish up that hockey goal with you, and then I wanted to help you guys get set up with these problems that you have to do for me in this worksheet. So let's see, for the hockey one, this is the hockey example, the one that we didn't get to do in class. Now it says that the center line of a hockey rink is 87 feet from the goal. The goal is 6 feet wide and 4 feet high. So let me draw a little picture here. 6 feet wide, 4 feet high. I'm going to ask, obviously, that you do the same thing. And I'm not drawing this to scale. I am not drawing this to scale at all. But from this point right here to this point right there, you are 87 feet. You are 87 feet away from that thing. I see you guys there in that chat. There you go. Now the question then becomes, well, what is the angle that you have? What is the wiggle room angle that you have? You're facing straight ahead. So if you hit straight ahead, assuming with enough force, you'll be able to make it into the net. But obviously if there's a little angle to the left, or there's a little angle to the right that you're trying to determine in order to figure out, well, what is your wiggle room angle here? And then I'll kind of recap it all with our previous notes. Again, all of my previous notes are actually in my classroom right now, so I don't have them, but I can still do this problem. The triangle that we're dealing with is this, with 87 being on the one side, and since this right here is half of the width of the goal, that would be 3 feet on that side. That's the triangle that we're dealing with. Obviously, this is 90 degrees. And the angle in question is theta. What is the wiggle room angle that we have for kicking or for hitting this hockey puck? I don't know. I mean, personally, I cannot skate, but let's figure this thing out. If this is the angle that we have, this is clearly the opposite. 3 is definitely the opposite. And well, clearly this one right here is the hypotenuse, so we're not going to worry about that because we don't know what it is at the moment. I mean, obviously we could figure it out, but I'm not worried about that. This is the opposite that we're dealing with. This is the adjacent that we're dealing with. SOHCAHTOA, you would realize that you are going to be dealing with tangent here. Tangent is TOA, opposite over adjacent. That's what you're dealing with. In order to solve something like that, again, arctangent would get this done. Arctangent of 3 over 87 would knock that thing out as what you did in geometry. Who are the geometry? I think it's Scody, Liston, Cherry. I think Scody teaches it. I'm not sure. Whatever. I'm not too worried about that right now. But anyway, I'm On my calculator, I would do arctan, again, making sure it's arctan, which is second tan. You would have to make sure your mode is set into degrees of 3 divided by 87. Again, I apologize for the quality of my calculator right now. And this gives you a theta of approximately 1.97 degrees. 1.97 degrees. Now, is that enough? I don't know. Let's recap something. There were three choices that you had. One was golf. What was the angle of error that you had in golf? We figured this out. Together last time, and for golf, the angle of error was approximately 1.01 degrees. That was the little angle of wiggle room that you had in terms of, well, if I'm off, if I don't hit it perfectly straight, what's my wiggle room to the left and the right? For soccer, the angle of error was approximately 4.57 degrees, meaning for soccer, I could have missed the kick straight by about 4.5 degrees to the left or 4.5 degrees to the right, and I still would have made it. And for hockey, as we just did, was 1.97 degrees. Your best opportunity for winning the $1 million, assuming that you kick it hard enough, is playing soccer, which most of you picked. So, good for you. Fantastic. Yay, oh happy day. Okay. Now, there are a bit more things I want to do in terms of angles, but I am going to save that particular lesson for Wednesday because I am going live again on Wednesday to teach you a brand new lesson. I'm going to relate it to the punting thing that we did last week because I left that a little bit behind, but I am going to return to that. But what I want to do to wrap up today is to help you set up this worksheet. Now, this worksheet, let's see if I can bring this up on my screen real quick. This particular worksheet, again, I made live in Google Classroom for you all. Let's see if I can't bring this up here. Come on. Again, I'm working from home, trying to get these things set up. It's much easier to get them set up in my classroom than it is here. But of course, you all have this available to you in Google Classroom. And I'm getting many more messages and emails as I'm doing this. So let's see if I can change this over, because I believe that I can. Let's go over here. Yes! Look at that! How awesome is that? Look at that. Look how good I am there. Can I make this larger? I would like to. Look at that. Look how wonderful that is. Oh my gosh. Hold on. Let's see if I can make this larger this way. Nope, I don't want to do that. Well, I'll do that. There we go. So yeah, that's what we got right there. Look at that. Sorry, I'm just so excited that that worked. The internet. Anyway, so this is what I'm working on. Of course, the PDF is available in your Google Classroom, so please, by all means, why is that not switching over? Leave it there. There we go. Good, 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 good. So the first one, number one, and then I'll flip back over to my top-down setting in a moment. Number one, Manning is trying to hit Wes Welker for a 25-yard gain in a crucial part of the game. If Manning drops back 5 yards and Welker's lined up 20 yards to the right, at what angle would Manning turn and the ball travel to hit Welker for a 25-yard catch? Now again, my goal of right now is to help you set up these problems. You are going to finish solving them as part of that assignment on Google Classroom. So keep that in mind. So if I'm talking about Wes Welker, let me jump over here to top down. There we go. Top down. Setting up the situation. There's Manning. And there's Welker. But of course, they are approximately 20 yards to the right. But it's not exactly, well, yeah, 20 yards to the right. But keep in mind that Manning's going to drop back 5 yards. Okay, this is not drawn to scale whatsoever, mind you. This is not drawn to scale. So, he's 20 yards to the right. There's Manning. There's Welker. He drops back 5 yards, and he wants to throw a 25-yard catch, which means this is going to be 30 yards right there. Yeah. It's going to add a little bit to it. If he's going to drop back and do that and throw that. No, 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 no. Those 30 yards are not there. Those 30 yards are not there. It's a 25-yard catch from the thing. Yeah, so he's going to run 25 yards. Right, yeah, but he is going to drop back 5 yards. I'm just figuring this out in my head as I'm talking to you. It's all good. It's all good. Just making sure that this thing is the way that we need it to be. Excellent. Now the angle, this is totally not drawn to scale. The angle that Manning is turning is the unknown theta right there. That's the unknown. The angle at which he has to turn. That's the setup to the problem. The question is, at what angle would Manning have to turn and the ball travel to hit Welker for a 25-yard catch? This is the proper setup to the problem. This is the proper setup. Now, again, I'm not going to solve this for you. I am not going to solve this for you. You are going to solve this for you. But that's the proper setup. Let's take a look at number 2. We flip back over here. Go to here. There we go. Good, good, good. Number 2. A hockey player is standing 20 feet directly in front of the net. The net's 6 feet wide, 4 feet high. The player shoots the puck and hits the top center crossbar. The question is, what is the angle of elevation that he shot the puck at for this to happen? Now, this is going to be an interesting problem because this is unlike stuff that we've done before, of course. So, I'm going to draw a little bit of a 3D perspective on this problem, so to speak. So, imagine for a moment that this is the net that we're dealing with. Okay, I know it's a little bit, I'm trying to angle the perspective. It's 6 feet wide and it's 4 feet high. Okay, it's a weird perspective shot. It hit the top center, and that was the shot. Let's say it kind of was elevated. Again, this is from a 3D perspective, and there's the puck when it was hit. That's the floor. That's the ground. I'm not going to connect it because, again, perspective. There's the angle that we are trying to figure out right there. What is the angle of elevation of this puck as it was hit? Let me fix that little 6 right there. Make it a little better. There we go. That's a 6. Now, you know what? I will connect it. Whatever. I will connect it. 20 feet in front of the net. So there's 20 feet right there. Interesting. Very interesting. Let's talk about the triangle that we're dealing with. The actual triangle that we're dealing with is something like this. There's theta, and there's 20 feet. The puck, if it's going to hit dead center on the crossbar, is going to rise 4 feet. It's going to rise about 4 feet. That's the setup to the problem. There's the puck. There's the crossbar. And the question is, what is the angle of elevation? You would have to solve that. Nice. Very nice. Number 3. Now, number 3 is going to be interesting. Let's kind of walk through it and see if we have enough information in order to get this thing done. Alex Rodriguez hits the baseball at 70 miles an hour at an angle of 30 degrees. How far does the baseball go in a horizontal distance? And how long does it take for it to get there? Now, this is an interesting type of problem. It's a very interesting type of problem. You have the 30 degrees, and you're trying to figure out how far the baseball actually goes. Now, actually, you know what? I'm going to scratch how far it goes. I'm going to scratch how far it goes. And I actually am going to modify this problem ever so slightly because I just want you to answer half of this question. All that I really want you to answer is how long does it take for it to get there? How long is the ball in the air for? That's what I really want you to answer. But in order to answer that, in order to answer said question, you're going to need the following formula. A formula that I have not talked about yet. But again, this is what I want to do with this worksheet. I want to set up these problems for you and then you solve them on your time. Here's what you're going to need. And I'm going to write this out very deliberately. And I'll explain exactly what is going on here. Now, you may have never seen this before in your life. And that's fine. That's totally fine. T is time in the air. That's time in the air. V sub 0 is the initial velocity. And theta is the angle of elevation. That's all you need. I'm going to actually, when the time is appropriate, I'm going to let you guys finish that problem, of course. Now, how far the ball actually goes horizontally, that's a different lesson. How far it goes horizontally, that's actually a different formula that I'm going to introduce to you guys on Wednesday. But for now, that's all you need. I'm going to let you guys figure that one out using that formula and using those pieces of information. That little subscript of 0, by the way, just for the sake of argument, doesn't have anything to do with the calculation. That little subscript of 0 is really just identifying it as an initial velocity. But I digress. Let's go back for the last one. If Carson Wentz... Oh, you can't see it. Hold on. There we go. Move that up there. There we go. If Carson Wentz dropped back 4 yards from the line of scrimmage, turned 20.3 degrees to the left, and completed a pass to Alshon Jeffrey, who was lined up 20 yards to the left, how far of a gain did the Philadelphia Eagles get? Now, I bring you back to the top problem right here. This problem right here. Now, we figured out that this should have been 30. Because, yes, it was a 25-yard gain, but Manning dropped back an additional 5 yards in order to get that thing done. But it was a 25-yard gain. For this problem, they're trying to figure out how much the gain was, given that he does do a 4-yard drop back. So after you get a possible answer, you may have to adjust that answer by 4 yards in order to account for the drop back. But again, the goal of this is me setting it up for you and then you finishing it for the assignment that is on Google Classroom. So, let's draw a triangle out. You know what? No, I got to draw a better one. He's to the left. He's to the left. So if he's to the left, I'm going to draw it like this. There we go. The angle is 20.3 degrees. That is the angle that he turned to the left. He was lined up 20 yards to the left. 20 yards to the left. And there was a 4-yard drop back. So now I'm not going to put the 4 on just yet. I'm not going to touch the 4 yards just yet. I will have to adjust my answer by 4 yards in order to get this thing done correctly. What are we solving for? We need to solve for that x. We need to solve for that x. My suggestion to you in doing this problem, you need to set up something using SOHCAHTOA. You need to set up something using SOHCAHTOA. And ultimately, you're going to solve for x. Now, this is part of the challenge that I have for you. Now, this is part of the challenge that I have for you. I want to see what you can do with this. I want to see what you can do with this. Again, the 4 yards, you're going to have to adjust the answer by 4 yards in order to account for the 4-yard drop back. We'll deal with that later. Compare it to what you did up here with Peyton Manning. But I want to see what you can do with this. So, because of the circumstances of today, because of the circumstances of what we're dealing with, I am going to end this particular live stream now, in a few minutes really. Let me just clarify a couple of things. And with the time that you have left, I want you finishing this worksheet. Now, thank you for being here this morning. You have a giant head start on everyone else who didn't show up. You do. You have graphing calculators on your Chromebooks. You have the ability to do these things. Make sure you change the mode from radians to degrees. You need it in degrees in order to get this thing done correctly. And if you need to reference this lesson, please by all means reference this lesson and the previous lesson that we did. So, if you have any additional questions, of course you can email me. But otherwise, I am going to be signing off on this live stream and sending you guys on your way. Remember, this assignment is due Wednesday. I'm not giving you all week to get it done. It's due Wednesday. So I'm expecting you to get it done. On Wednesday, I will have an update for you in terms of fantasy football. On Wednesday, I will introduce the last couple of formulas that I need in order to wrap up angles in football, including going back to punting a little bit. It's going to be great. One thing that I'm really, really, really sad about, Liston, when he taught this class, he wasn't teaching under pandemic conditions. And when he did the football unit, he was able to take his class out to the football field and actually attempt kicking field goals and stuff like that. Like, we would do the math behind it, like distance and angles and all that other stuff, and then they would actually go out and attempt kicking field goals, which I thought was awesome. And I was so looking forward to that when I knew I was taking over the class last January. And I was like, oh my gosh, that would be so stinking awesome. And now, the 84-minute class period is down to 60 minutes, and I can't live stream from up there, and we can't just walk through the hallways as a group and just go up to the football field on a whim. And now we're all quarantined. So, oh, happy day. So I do apologize for not being able to do that with you guys. But yeah, those are the circumstances that we're in. Anyway, like I said, I'm going to sign off. I'm going to expect now this class period technically runs all the way to 9:24. So you do have an additional 15 minutes, which you can get started on this assignment that is in your Google Classroom. And I would obviously expect you to. But this is due Wednesday. So take your time, email me any questions that you got, and we'll see you guys on Wednesday. Thank you, and good morning, night, good afternoon, whatever. Goodbye.